The 5, you know the 6 now? It's going to be your equilibrium.
Oh, really?
I know, right? So, we think of the 5, I mean, our top 5, okay? Who knew? Alright, had that general sense of touch, and look, just to give y'all an idea of how old I am. It used to be that the only picture that they showed of the general sense was the hand. So I used to think that the only general sense I had was from my hand. No. You've got it all over the body. Okay? Alright. Then we've got sight, smell, taste, hearing, and to that they've added equilibrium. Every single one of these, which is a sensation, okay, your sensory information, housed in bones. Stand up. So, Dave, I have a big weekend. Okay, so then when you get to studying some of this stuff on the skull, it is so cool, okay? Because when you look at the structure, for example, of this mandible to the skull, it has some really cool articulations. Then we have bones, such as the temporal bone, the zygomatic bone, but get this, the zygomatic bone contains the temporal arch, the temporal contains the zygomatic arch. Now tell me that's not cool. Somebody was invented in lab that day. Okay? They were. So that is pretty cool. So when you get to studying it and looking at it, it does have some pretty cool terms that go along with it. This would be what we get to palpate on the patient. Alright? So, you know, if we have a patient, these are bones we get to palpate. I love to go to the doctor with a sinus infection, and she'll go, does that hurt? Well, what do you think? Okay? Well, then I guess you got, I told you I have something. I knew that already. But no, I think it's just the fact that she likes to just saying, you know. So, these are the areas that we actually get to palpate. Y'all gotta love that picture, right? Because we see that everywhere, don't we? Okay? When I met my now husband, go into the living room where the TV is, we got this long, you know, speaker thing sitting in front of it, and then these two things sitting on each end. And I'm like, because, you know, I don't have my good eyesight, I didn't have my glasses on. I couldn't let him know, you know, I had 3 glasses just yet. That comes on like the 4th or 5th day. So, you know, they're sitting up on this, you know, the speaker, and I'm going, and then I was like, oh, cool, you know, because it was the little skull, all right, because that's what they look like. And this right here, I think, gives a really good view on the sinus veins, okay? Being able to get you a good view when you begin to look at, like, the lateral bone, the sphenoid bone, when we get into looking at, like, the nasal bone, these bones that would be behind the eye, behind the eyeball, as we think of it. Once again, areas that we could actually palpate, either on someone else or yourself. The orbit of the eye, that's a good picture once again. When you begin to look at the plastic skulls that we have like in the bone box, they're going to be a little difficult to identify some of these bones. okay? Because ours are plastic, okay? And the structure of them is just not as good, all right? So you'll be able to look at it and go, oh, well, okay, look, there's the lacrimal bone, and there's the sphenoid. You'll be able to do a few of them, okay? Be sure to take a peek at what we're going to have over here, because they have actually taken these bones and taken them and, like, broke them into their component pieces, okay? And they should be in the box. You'll see that the boxes are numbered, like number 8, number 10, number 13, that sort of thing. And when you get them out, be sure to put them back where they belong. If you happen to look through the box, something's not where it should be, just kind of put it where it is. I'm not sure how many, professors before me make sure that everything's in the right box, but you'll usually see the number written on it, correlating with hopefully what's in the little tray right here, okay? The skull takes up quite a bit because there's so many bones. The nasal cavity. Now, have y'all ever thought about your nose? Have you ever thought about the fact that the air around you is either, for the most part, warmer or colder than the air that has to go into your lungs? Because what is that internal temperature supposed to be?
Around
98.6, okay, for us. All right, 37 degrees Celsius, I think. How is it that I can be right here, breathe in air that's maybe 70 degrees, but by the time it gets to my lungs, so that my lungs don't get the brain freeze, okay? I know what brain freeze is, right? When you eat ice cream or something cold really quick. Okay, how is it that my lungs don't get the brain freeze every time I breathe? Okay? We've got these really cool structures in this nasal cavity. Now see these little flaps right here? These little flaps, these concha, that they look like the shell on a seashell, okay? They have the ability with the soft tissues in there to create a turbulence in the air we breathe so that it warms it, moistens it, and sends it to our lungs. Is that not the coolest thing? I mean, okay, so bones of the nasal cavity, some of these you need to be familiar with. The sinuses, definitely check over those because you've got to be familiar with some of the sinuses. When we look at the cranial cavity, like I was pointing out, in the base of the skull, okay, versus the upper portion of the skull, because that's definitely more flattened on the inside, but that base of the skull has a lot of structure to it, and it has a lot of like bumps and hills and valleys and ridges and lines and so forth because of the fact of the tissues that it's housing. So it does have some different terms that go with it. The hole that you find at the base of the skull, foramen magnum. Magnum, large, okay, foramen. Anytime you hear the term foramen, that means hole, okay? Because you're going to find that we have a mental foramen, and I always wondered why that was. I think I know now, but that's just me, okay? I'll tell y'all in a minute. Now, the foramen magnum, okay, is of course the area that the spinal cord exits. Okay, so, just letting you know that there is some logic to those terms.
It's not good when your brain wants to go through that hole.
No, it is not. If there is a compression, actually, the part that is the most crucial when it comes to brain damage, all right, the part that is most crucial is your brainstem. Anything that affects the brainstem most likely is going to cause death. Because of the fact that it is running all of these different parts about your body, like rate of respiration, heart rate, blood pressure, temperature of the body, it is monitoring. I mean, you know, look it up sometime what all everything gets monitored there. And that is the area that's for life. Okay? So damage to that area, definitely not a good thing. Okay, so some more pictures of the skull. Once again, get into some more pictures of the skull. Right? Okay. Other parts, these terms, all right, that I want you to be familiar with, stuff like the process, the fossa, a condyle. Okay. A lot of those terms are found on the bones of the skull. A lot of them. So this is kind of showing, for example, the styloid process. You're going to probably, I think that's one of them you need to know, basically how the skull and the vertebral column join together. More of the different features that are found on the bones, like the fissures, the foramen, the canals, all right, explaining everything about the skull. Anybody who goes into this line of orthopedics, okay, they get my thumbs up, okay, because the skull is amazing. The auditory ossicles, those little bones of the ear, yes, they are bones, and they do count. 3 in each ear, okay? So don't forget those little auditory ossicles. When we begin to separate the skull, we are going to say that we have our brain case, neuro, meaning brain, nerve tissue, cranium, so that's here, and then viscera, because they call those, like the eye, the tissues of the nose, our mouth, our ears, organs of sense, okay? Like organs of sight, organs of smell, organs of taste, organs of hearing, organs, another term for that, viscera, okay? So these protect the viscera. So viscerocranium, which is kind of cool. Now, the next few slides, we're going to begin to take them bone by bone. Like I said, I'm not going to read them. So that begins to break down what you see right there in that box. Basically, just taking them apart like the pieces of a puzzle. Lets you know the location, and the top picture gives you different views, a posterior, anterior, and a lateral view, and the different processes and so forth of that bone. Some of these you're going to have to know for that last test. So I would just kind of go through, check it, maybe highlight the ones that you're going to have to be familiar with, identify them on the on any of these models that we have in the classroom, all right, and learn those particular bones. Now, the hyoid bone. With the hyoid bone, it's the coolest bone ever, okay? Looks like vampire teeth. Does not articulate to any other bone. That means it doesn't have a spot that touches another bone. It's held in place by all of these cool ligaments and so forth. Now, one of the things about the hyoid bone, it gives support to the tongue, okay, so that we have this ability to talk and that sort of thing. And it's usually the bone that gets